Tonight, we're going to ask a question so simple that almost everyone believes they already know the answer. It isn't a question about black holes, alien civilizations, or even the Big Bang. Instead, it's a question that exists beneath every star, every galaxy, every atom, and perhaps beneath reality itself. It's a question that has challenged philosophers, scientists, and mathematicians for thousands of years. Why does anything exist at all? Take a moment and picture the night sky. Thousands of stars shine against the darkness, while beyond them lie billions of galaxies, each containing billions of suns. Somewhere in that unimaginable expanse are planets we've never seen, places no human will ever visit, an ancient light that has traveled for billions of years just to reach Earth. The universe feels overwhelmingly full of light, matter, energy, and structure. It appears to be a cosmos overflowing with things that exist. But what if all of those extraordinary objects distract us from the greatest mystery of all? Before there were galaxies, before there were stars, before there were atoms, there is a question that refuses to disappear. Why wasn't there simply nothing? At first, the answer seems obvious. Most of us imagine nothing as an empty room. Remove the furniture, remove the air, turn off the lights, and eventually all that's left is emptiness. Scale that idea up to the cosmos, and it feels natural to imagine an empty universe waiting for something to appear. It's such an intuitive picture that very few of us ever stop to question it. Yet for thousands of years, humanity's greatest thinkers kept running into the same paradox. The problem wasn't explaining the universe. The real problem was explaining nothing. That may sound impossible, but it is true. We've built telescopes capable of seeing billions of light years across space. We've landed robots on distant worlds. We've even detected ripples in spacetime itself. And yet one of the simplest words in our language remains one of the hardest to define. What exactly is nothing? Is it an empty place? Is it the complete absence of everything? Or is it something far stranger than our intuition has ever allowed us to imagine? The deeper modern physics explored this question, the more unsettling the answers became. Scientists discovered that reality behaves in ways no human being would ever predict from everyday experience. Space can expand, time can slow down, gravity can bend light itself. Again and again, nature has shown us that our common sense is not a reliable guide to the universe. That realization forces us to consider something deeply uncomfortable. If our intuition is wrong about space, wrong about time, and wrong about gravity, could it also be wrong about nothing? Perhaps the greatest misconception in human history isn't about the stars above us, but about the emptiness between them. And if that emptiness isn't truly empty, then the question we've been asking for centuries may itself be incomplete. Maybe the universe didn't emerge from nothing at all. Maybe we've never understood what that word actually means. Before we can explore the Big Bang, quantum physics, or the birth of the cosmos, we first have to travel much further back, not billions of years into space, but thousands of years into human history. Because long before the first telescope looked toward the heavens, people were already arguing about whether nothing could exist at all. And surprisingly, those ancient debates would eventually lead to one of the greatest scientific revolutions in history. So before we ask how the universe began, we have to answer a much stranger question. What does nothing actually mean? For most of history, nothing was a dangerous word. Ancient philosophers didn't just find it confusing, they found it impossible. To them, the idea of a true vacuum, a place where literally nothing existed, was a hole in the fabric of reality that nature would never allow. They famously said, "Nature abhors a vacuum." They believed that if you tried to create an empty space, the universe would rush in to fill it with such violence that the vacuum itself would vanish. And for over 2,000 years, we agreed with them. We assumed that the universe was like a giant container, and that nothing was just the name for the empty space inside it. But as we entered the age of modern physics, we realized we had it backwards. We discovered that space isn't just a stage where stars and planets perform. Space itself is a thing. It can be bent, it can be stretched, and it can even be torn. This changed everything. It meant that the emptiness between the stars was just as real as the stars themselves. If you take away all the matter and all the light, you aren't left with nothing. You are left with the fabric of spacetime, a vibrating, energetic grid that is far from empty. This led scientists to a realization that sounds like it belongs in a science fiction novel. They began to wonder, if the universe is made of matter and energy, and both of those things have a cost, then who paid for it? In our everyday lives, you can't get something for free. If you want to build a house, you need materials. If you want to move a car, you need fuel. So if the Big Bang created billions of galaxies, where did all that staggering amount of energy come from? How did the cosmic bank account start with zero and suddenly end up with trillions? The answer, as it turns out, might be the most elegant trick the universe ever played. Physicists discovered that there are two types of energy in the cosmos. There is positive energy, the kind we see in light and matter. But there is also negative energy, the kind stored in the pull of gravity. When a scientist tries to calculate the total energy of the entire observable universe, they find something haunting. The positive energy of matter and the negative energy of gravity seem to cancel each other out perfectly. If you add up everything we see and subtract the gravity that holds it together, the final number is 0. If this theory is correct, it means the universe didn't actually require something to be created. It means that everything we see, the sun, the earth, the person sitting next to you, is just one side of a cosmic equation that still equals nothing. It's as if the universe is a massive loan that never has to be paid back because the debt and the credit are exactly the same. We aren't living in a world of stuff. We are living in a highly organized, beautifully complex version of nothing. Our existence isn't a violation of the rules, it's just a very clever way of hiding the emptiness. But if the total energy of the universe is 0, and nothing is our true origin, then why is the universe so busy? Why didn't it just stay empty? If you have a perfectly balanced scale, something still has to tip it for the first time. Something had to trigger the silence to become a scream. And to find that trigger, we have to look closer than any microscope has ever dared to go. We have to dive into a world where logic fails and particles pop in and out of existence like ghosts. Because as it turns out, nothing isn't just a 0, it's a battlefield. And in our next section, we're going to witness the chaos that happens when nothingness starts to boil. Imagine for a moment that we could take a cubic meter of empty space, the space between the stars, far away from any planet or galaxy, and we could somehow scrub it clean. We remove every stray atom of hydrogen, every passing photon of light, and every ghost-like neutrino. We shield it perfectly from any magnetic fields or distant gravitational tugs. We are left with what we would call a pure vacuum. In our everyday language, we would look at that box and say it contains absolutely nothing. But if we were to zoom into that box, not just 1,000,000 times or 1,000,000,000 times, but down to the very fabric of reality itself, we would discover something that defies everything we know about the world. At that microscopic level, the nothing inside the box isn't quiet, it isn't still. Instead, it is a violent, churning cauldron of activity. It's as if the vacuum is a restless ocean that can never stay calm. This is the world of quantum mechanics, and it teaches us that nothing is actually one of the most unstable things in existence. According to the laws of physics, it is fundamentally impossible for any part of the universe to have an energy level of exactly 0. Because if the energy were exactly zero, we would know exactly where everything is and exactly how it's moving, and the universe, at its most basic level, refuses to be that predictable. Instead, nothingness is constantly simmering. Tiny particles are popping into existence out of thin air, pair by pair, only to collide and vanish back into nothingness a fraction of a second later. These are called virtual particles, and they aren't just a mathematical trick. They are real, they exert pressure, they affect the atoms in our bodies. The vacuum of space is more like a crowded room, where the lights are flickering so fast that you only catch glimpses of the people inside before they disappear again. This realization leads us to a staggering conclusion. Nature doesn't just abhor a vacuum, it finds nothingness unbearable. The void is so heavy with potential that it is constantly trying to become something. It's as if the universe is a tightly wound spring, and even in the darkest, emptiest corners of space, that spring is vibrating with an energy we are only just beginning to understand. But if the vacuum is always boiling with these tiny, ghost-like particles, it raises a question that should haunt us. If nothing can produce a few tiny particles for a fraction of a second, could it have produced something bigger? Could the entire universe, every star you see, and every person you've ever met, be nothing more than one of these quantum fluctuations that simply grew too large to vanish? To answer that, we have to look at the one moment in history where the rules of the universe didn't just bend, they broke. We have to look at the birth of time itself. Because if the universe is a free lunch, as some physicists say, then the Big Bang wasn't just an explosion. It was the moment the void finally lost its balance. But what could have pushed it? What could have caused a single, microscopic spark in the nothingness to expand into 100 billion galaxies in less than a heartbeat? To understand that, we have to travel to a place where time and space cease to exist, a place where the very concept of before has no meaning. If the vacuum of space is constantly churning with these tiny ghost-like particles, then nothingness is more like a minefield than a blank canvas. Every square inch of the void is filled with energy that is looking for an excuse to explode. For most of eternity, these tiny quantum bubbles simply pop in and out of existence, canceling each other out before they can do any real damage. They are like sparks from a fire that go dark before they hit the ground. But billions of years ago, something happened that shouldn't have been possible. In a state of absolute nothingness, one of those tiny quantum sparks didn't go out. Instead of vanishing back into the void, it stayed. It caught onto a strange, hidden property of space itself, a kind of repulsive gravity, and it began to grow. This wasn't just a small expansion, it was a violent, exponential runaway effect. In less than a billionth of a second, a speck of nothing that was smaller than a grain of sand inflated to become the size of a galaxy. This is the moment we call the Big Bang, but it wasn't an explosion in space. It was the explosion of space itself. Everything we see today, every star, every mountain, every drop of water, is essentially a piece of that original quantum spark that got frozen into reality. We are the leftovers of a cosmic accident. But if the entire universe came from a single microscopic fluctuation, it leads to a conclusion that is even more mind-bending. If our universe was born because nothing became unstable, then what's to stop it from happening again? If space is still filled with this boiling quantum energy, then the Big Bang might not have been a one-time event. We might be living in just one bubble in a vast, infinite ocean of bubbles, a multiverse where universes are popping into existence every single moment. But there's a problem with this beautiful picture. If the universe started as a perfect, smooth expansion of energy, why isn't it still just a smooth cloud of gas? Why did the energy clump together to form stars, planets, and people? Why is the universe lumpy instead of a perfect, empty mist? The answer lies in a tiny, microscopic flaw that occurred during that first second of creation. A mistake in the math of the universe that allowed gravity to take hold. And to understand how that flaw created us, we have to look at the first light ever to shine in the cosmos, a light that is still echoing around us today, if you only know where to look. If you ever owned an old television, the kind with an antenna and a screen full of flickering gray static, you've actually witnessed the birth of the universe with your own eyes. About 1% of that, snow, dancing on the screen, is actually the interference caused by the afterglow of the Big Bang itself. It is a ghost of a world that existed long before the first star was ever born. For decades, this static was just considered noise, a nuisance of technology, but to a physicist, it is the most important message ever sent. It is a cosmic fossil that contains the secret of why the universe isn't just a cold, empty graveyard of gas, but a home for complex life. To understand why this message is so vital, we have to imagine the universe as it was 380,000 years after the initial spark. At this stage, the cosmos was nothing like the dark, transparent void we see today. Instead, it was a thick, blindingly hot orange fog of plasma. It was so dense and so energetic that light itself couldn't travel. Imagine being inside a sun that is the size of the entire universe. If you tried to turn on a flashlight, the light wouldn't go anywhere. It would instantly bounce off the crowded particles around it, trapped in an endless game of cosmic pinball. The universe was opaque. It was a world of pure, trapped energy where nothing could be seen and nothing could grow. But as the universe continued to expand, it began to cool. And then in a single, silent moment of cosmic history, something miraculous happened. The temperature dropped just enough for atoms to finally form. The fog literally cleared. For the first time, light was liberated. It broke free from the plasma and began to stream across the cosmos in every direction. This was the first dawn, the first time the universe became transparent. And that very first light has been traveling through space for 13.8 billion years, stretching and cooling until it became the faint microwave hum that we can still detect today. When scientists finally managed to take a picture of this ancient light, they expected to see a perfectly smooth, uniform glow. After all, if the Big Bang was a perfect expansion, the heat should be spread out evenly, like a glass of room temperature water. But what they found instead was something that sent shivers through the scientific community. The map of the first light wasn't smooth. It was covered in tiny, microscopic freckles. Some spots were just a fraction of a degree hotter than others, while some were slightly cooler. At first glance, these spots look like random noise. But these tiny imperfections are actually the fingerprints of the quantum fluctuations we talked about earlier. Those tiny, boiling bubbles from the void didn't just disappear. They left their mark on the temperature of the entire universe. These freckles were the seeds of everything. The slightly hotter, denser spots had more gravity. They began to pull in the surrounding gas, growing heavier and heavier over millions of years. These tiny flaws in the early universe are the reason that galaxies exist today. Without these microscopic mistakes, the universe would have stayed a smooth, boring cloud of hydrogen forever. There would be no stars, no planets, and no you. But as we look closer at this cosmic map, we find something even more disturbing. While most of the spots follow the rules of physics, there is one area that shouldn't be there. A massive, cold void in the map that is so large it defies every mathematical model we have. It's a place where the energy of the Big Bang seems to have been sucked away. Some scientists believe this isn't just a random gap. They believe it might be the bruise where our universe bumped into another one. Could the very light that proves our origin also be showing us the exit door? Could we be looking at the point of contact with an entire reality outside our own? To find out, we have to follow those seeds of gravity, as they grow from tiny freckles into the first giants of the cosmos. We have to witness the moment the universe went from a simple cloud of gas to a complex machine of fire and light. And the first things to wake up in that darkness were monsters that shouldn't have been able to exist. Imagine the most profound silence you have ever experienced. After the blinding flash of the first light, the one we still see as static on our TV screens, the universe did something unexpected. It went dark. For the next 100 million years, there was no light, no heat, and no activity. This era is known as the Cosmic Dark Ages. It was a time when the universe was nothing more than a vast, expanding ocean of cold hydrogen and helium gas, drifting aimlessly through an absolute, terrifying blackness. If you were standing in the middle of the cosmos during this time, you could look in every direction for an eternity, and you would never see a single spark. It was a universe that seemed to have died in its infancy. But beneath the surface of that darkness, an invisible force was working. Gravity, the patient, relentless sculptor of the cosmos, was busy. It began to hunt for those tiny freckles and imperfections we found in the early light. Like a magnet pulling iron filings out of the sand, gravity began to draw the cold gas together into massive, swirling clouds. For eons, these clouds grew heavier and denser, collapsing under their own weight. They were becoming cosmic pressure cookers, getting hotter and hotter with every passing millennium. The tension was building toward a breaking point, a moment where the nothingness of the Dark Ages would finally be shattered by the most violent transformation in history. Then, in a single, localized moment of unimaginable heat, the first star ignited. It wasn't a small, stable sun like the one we orbit today. The first stars of the universe, the population III stars, were monsters. They were hundreds, perhaps thousands of times more massive than our sun, burning with a fierce, brilliant blue-white light that would have been blinding even from light years away. When the first of these giants turned on, it didn't just illuminate the darkness, it tore through it. These stars were so energetic that they began to strip the electrons off the surrounding gas, literally relighting the universe. This was the second dawn, the moment the cosmic dark ages ended and the age of light began. But these first giants were born with a tragic curse. Because they were so massive, they burned through their fuel with a suicidal intensity. While our sun will live for 10 billion years, these first stars lived fast and died young. In just a few million years, a mere blink in cosmic time, they exhausted themselves. But their death was even more important than their life. When these first stars ran out of fuel, they didn't just fade away. They exploded in supernovae, so powerful that they could outshine entire galaxies. In the heart of those explosions, something miraculous happened. The simple hydrogen and helium were crushed together to create the first heavy elements: oxygen, carbon, iron, and gold. Every atom in your body, the calcium in your bones, the iron in your blood, the oxygen you are breathing right now, was forged inside the fiery bellies of these first monsters. They died so that the chemistry of life could exist. They seeded the universe with the ingredients for planets and eventually for us. We are, in the most literal sense, the recycled ashes of these long-dead titans. The universe was no longer just a collection of gas and light. It was becoming a factory for complexity. It was learning how to build stuff. But as these first stars collapsed, they left behind something that even gravity couldn't control. In the spots where the most massive stars once stood, they left holes in the fabric of reality itself. Dark, bottomless pits that began to swallow everything around them, light, gas, and even other stars. These were the first black holes, the seeds of the great galactic empires. And as these black holes began to grow, they started to drift toward one another, preparing to engage in a cosmic dance that would decide the fate of the entire universe. But what happens when these monsters finally meet? And how did they build the massive structures we live in today without tearing the whole thing apart? To understand that, we have to look at the cosmic web, the invisible skeleton that holds everything together. And as it turns out, the most important part of that skeleton is something we can't even see. If you look up at the night sky, you see stars. If you look through a telescope, you see galaxies. It is natural to assume that what we see is what exists. But if you were to weigh the entire universe based only on the light we can see, the math would tell you something impossible. It would tell you that the universe shouldn't exist. Every galaxy you see, including our own Milky Way, should have flown apart billions of years ago. We are living in a cosmic house that has no visible pillars, no visible walls, and yet it refuses to collapse. To understand this mystery, we have to look at how galaxies spin. Imagine a child's carousel in a playground. If the carousel spins slowly, the children can hold on easily. But if you spin that carousel at 1,000 miles per hour, the children would be flung into the air by centrifugal force. Galaxies are like those carousels. They are spinning at hundreds of kilometers per second. When astronomers calculated the amount of stuff inside galaxies, the stars, the gas, and the dust, they realized there wasn't nearly enough gravity to hold them together. Based on the visible matter, every galaxy in the sky should be disintegrating, spraying stars into the deep void like water from a lawn sprinkler. But they aren't. Something is holding them. Something invisible, silent, and incredibly heavy is acting like a cosmic glue, wrapping its arms around every galaxy and pinning the stars in place. In the 1970s, an astronomer named Vera Rubin confirmed this terrifying reality. She realized that there is a ghost in the machine of the universe. For every gram of normal matter we can see, the atoms that make up your body, the phone in your hand, and the stars in the sky, there is at least 5 times more, something else that we cannot see. We call it dark matter, but that name is a confession of ignorance. We don't call it dark because it's the color of the night. We call it dark because it is completely invisible to every tool we have ever invented. It doesn't reflect light, it doesn't emit heat, and it doesn't block distant stars. You could have a mountain of dark matter passing through your living room right now, and you would never know. It is a phantom substance that only speaks through the language of gravity. This leads us to a humbling realization. Everything we have ever studied in the history of science, every element on the periodic table, every planet, every sun, is just a tiny 5% impurity in a universe dominated by a shadow world. We are like children living in a massive skyscraper, thinking the building is made of the wallpaper and the paint, never realizing that behind the walls, there is a massive skeleton of steel and concrete that we've never seen. But if dark matter is the skeleton, then what does the body of the universe actually look like? If we could somehow turn off the light of the stars and only see the pull of this invisible glue, we would see that the universe isn't a random collection of galaxies. Instead, it is a structure so vast and so organized that it challenges the very idea of chaos. It is a masterpiece of cosmic architecture, and we are just the dust caught in its threads. If we could zoom out so far that entire clusters of galaxies looked like tiny grains of sand, we would see the true shape of our reality. The universe isn't a cloud, and it isn't a soup. It is a web. Astronomers call it the cosmic web. Imagine a giant, 3-dimensional spiderweb stretching across billions of light years. The silk of this web is made of invisible filaments of dark matter. These filaments act like cosmic highways, pulling gas and galaxies toward them. Where the strands of the web cross, you find massive superclusters of galaxies, metropolises of light burning in the dark. This web is the largest structure in existence. It is the nervous system of the cosmos, and it explains why the universe looks the way it does. Galaxies aren't just floating randomly. they are growing along these invisible dark matter tracks. If you think of a galaxy as a leaf, the cosmic web is the branch it is attached to. This structure is so ancient that it was mapped out by those tiny quantum fluctuations we talked about at the very beginning of time. The freckles in the first light were actually the blueprint for this massive web. But as we study this web, we notice something eerie. Between the massive strands of light and matter, there are gaps. There are voids, gigantic empty bubbles where there is almost nothing. Some of these bubbles are hundreds of millions of light years across. These are the places where dark matter is thin, and because there is no glue, the galaxies have been sucked out toward the surrounding strands. We are living in a universe of cities and deserts, and the deserts are growing. This brings us to a terrifying question. If dark matter is the glue holding everything together, and the cosmic web is the structure of reality, then is the universe finished? Is this the final shape of the cosmos? For a long time, scientists thought so. They believed that gravity, both the visible and the invisible kind, would eventually win the war. They thought that one day, all this gravity might even pull the universe back together in a big crunch, returning everything to the 0 point from which it began. But in 1998, we looked at the most distant corners of the web and we realized we were wrong, dead wrong. We discovered that the web isn't just sitting there and it isn't collapsing. It is being torn apart. Something even more mysterious than dark matter is pushing against the skeleton of the universe. It is a force that doesn't want to build, it wants to expand. It is an energy that lives in the very vacuum of space itself, and it is currently winning the battle for the fate of the cosmos. We've spent billions of years watching gravity build this beautiful web, but now a new player has entered the game. A force so powerful that it is stretching the very fabric of existence until the threads of the cosmic web begin to snap. We call it dark energy. And if dark matter is the invisible ghost that built our home, dark energy is the monster that is going to tear it down. But what happens when the space between galaxies starts to grow faster than the speed of light? What happens to the nothingness when it starts to push back? To find out, we have to look at the darkest energy of all, and the terrifying end it has planned for every single atom in your body. For most of human history, we believed the universe was a static, unchanging stage. Then we discovered it was expanding, growing like a balloon being inflated. For decades, every physicist on Earth agreed on one thing, that expansion had to be slowing down. It made sense. Gravity is an attractive force, it pulls things together. After the initial push of the Big Bang, the billions of galaxies in the cosmos should have been acting like a fleet of cars slamming on the brakes. We expected that one day, the universe would either stop expanding or, more likely, collapse back in on itself in a fiery, big crunch. It was a logical, tidy ending to the story of everything. But in 1998, two teams of astronomers set out to measure exactly how much the universe was slowing down, and they stumbled upon a truth so disturbing it fundamentally broke our understanding of physics. They looked at distant, dying stars called Type 1a supernovae, cosmic light bulbs that always burn with the same brightness. By measuring how faint these stars were, they could tell how far away they were, and what they saw didn't make sense. The distant galaxies weren't just moving away, they were sprinting, they were accelerating. Imagine you are standing on a bridge and you throw a ball high into the air. You expect the ball to slow down as it reaches its peak and then fall back to your hand. But instead, as the ball leaves your fingers, it starts moving faster. It screams past the clouds, breaks the sound barrier, and vanishes into the stratosphere, moving quicker with every passing second. This is what our universe is doing. It's as if there is a hidden, invisible hand pushing the galaxies apart, fighting against gravity and winning. This mysterious force, which makes up about 70% of everything in existence, is what we now call dark energy. We have no idea what it is. We can't see it, we can't measure it in a lab, and it doesn't seem to interact with light or matter in any way, but we can see what it's doing to the nothingness of space. It appears that space isn't just a vacuum, it has an energy of its own. And as the universe expands and creates more space, there is more dark energy. This creates a terrifying feedback loop. The more the universe grows, the more dark energy there is to push it, which makes it grow even faster. It is an engine of expansion that is fueled by the very emptiness it creates. This revelation forces us to look at the future of our cosmos with a new sense of dread. If gravity was the architect that built the stars and the galaxies, dark energy is the demolition crew. It is currently engaged in a cosmic tug-of-war, stretching the threads of the cosmic web we talked about earlier. Right now, the gravity of our local neighborhood is strong enough to hold the Milky Way together. But in the vast, empty voids between galaxy clusters, dark energy has already won. It is creating new space so fast that light itself can no longer bridge the gap. We are witnessing the beginning of a cosmic isolation that will eventually change the face of the sky forever. But what does this mean for the end of the story? If this expansion continues to accelerate, we aren't heading toward a big crunch or a peaceful equilibrium. We are heading toward something much more violent. As space expands faster and faster, it will eventually exceed the speed of light. One by one, distant galaxies will cross a cosmic horizon and vanish from our sight forever. Their light will never be able to reach us again. If humans are still around in a few trillion years, they will look up at a sky that is completely, utterly black. They will live in a universe where they believe they are the only galaxy in existence, with no evidence that other stars ever existed. But even that isn't the most extreme possibility. Some scientists fear a scenario called the Big Rip. In this version of the future, dark energy becomes so powerful that it doesn't just push galaxies apart, it begins to attack the structures within them. First, it will tear galaxies away from their clusters. Then it will tear stars away from their planets. Finally, as the expansion reaches its breaking point, it will overcome the forces that hold atoms together. In the final fraction of a second, the very fabric of spacetime will be shredded. Every molecule, every atom, and every subatomic particle in the universe will be ripped into nothingness. It is a lonely, cold, and silent end to a journey that began with such fire and light. It suggests that our time in the universe is a rare, privileged window, a brief moment where the nothingness is balanced enough for us to see the stars. We are living in the golden age of light, a flickering candle in a wind that is getting stronger every day. But as we look at this expanding void and the dark forces governing it, we realize something even more strange. While dark energy is pushing everything apart, there are places in the universe where the rules of expansion simply don't apply. There are places where gravity has become so concentrated and so intense that it has effectively locked the door against the rest of reality. Inside these regions, space and time don't just bend, they stop making sense entirely. These are the graveyards of stars and the engines of galaxies. To understand where all this matter goes before the Big Rip can claim it, we have to look into the mouth of the ultimate predator. We have to understand the black hole. And as it turns out, the nothing inside a black hole might be the key to understanding how our entire universe began. Imagine you are sailing on a calm, dark river. The water is smooth, the stars are reflected on the surface, and everything feels peaceful. But as you drift further downstream, you notice a subtle change. The water begins to move faster. You try to paddle back, but the current is stronger than your muscles. Then you hear it, a low, thunderous roar. Ahead of you, the river simply ends. It doesn't drop into a waterfall, it falls into a hole in the world itself. You have reached the point where the laws of the river no longer apply. This is the closest we can get to imagining a black hole. But in the universe, the river isn't water, it is time and space itself. And once you cross that invisible line, there is no backwards. The very concept of a way ceases to exist. For decades, even Albert Einstein refused to believe these things were real. His own mathematics predicted them, but he called them a disaster for physics. He couldn't accept that nature would allow a place where the laws of reality simply commit suicide. But nature doesn't care about our comfort. We now know that the universe is haunted by these ultimate predators. They are the final stage of a star's life, a star that was so massive, so heavy, and so greedy for gravity that when it died, it didn't just collapse, it punched a hole through the fabric of existence. To understand a black hole, you have to forget everything you know about objects. A black hole isn't a thing in the way a planet or a star is. It is a region of space where gravity has become so intense that it has warped reality into a one-way street. Think of it like a trampoline. If you place a bowling ball on it, it creates a dip. If you place something infinitely heavy on it, the dip becomes a bottomless well. Light, the fastest thing in the universe, travels at 300,000 kilometers per second. It is the cosmic speed limit. But inside a black hole, the exit speed required to escape is higher than the speed of light. Because nothing can go faster than light, nothing can ever come out. Not even a whisper of information. It is the ultimate dark room from which no signal can ever be sent. But what would it actually feel like to approach one? This is where the horror of physics becomes personal. As you get closer to a black hole, you would first encounter the photon sphere, a place where gravity is so strong that light itself is forced to travel in circles. If you were standing there, you could literally look straight ahead and see the back of your own head, because the light from your body has traveled all the way around the black hole and back to your eyes. It is a hall of mirrors created by the bending of space. But as you drift past the light, you hit the event horizon. This is the point of no return. From the outside, anyone watching you would see something strange. Because gravity warps time, they would see you slowing down. To them, you would seem to freeze at the edge, turning a dark shade of red as your light stretches out, eventually fading into nothingness. They would never see you fall in. But from your perspective, time is moving normally. You cross the horizon, and in that moment, the universe behind you vanishes. You are now in a place where the future and the past have swapped places. In our world, no matter what you do, you will always move toward tomorrow. Inside a black hole, no matter what you do, you will always move toward the center. Space has become time. The center isn't a place, it is a moment in your future that you cannot avoid. Then the spaghettification begins. It's a playful name for a terrifying process. Because the gravity at your feet is millions of times stronger than the gravity at your head, your body begins to stretch. You are pulled into a thin, long string of atoms. You are no longer a person. You are a stream of subatomic particles being fed into the mouth of a monster. And at the very center lies the singularity. This is where the word mystery isn't big enough. The singularity is a point of infinite density. It is a place where a mass millions of times greater than our sun is squeezed into a space of zero volume. Here, the math of Einstein and the math of quantum mechanics scream at each other and break. Space and time, as we understand them, simply end. It is the edge of the map. But black holes aren't just cosmic trash cans. They are the engines of the universe. At the heart of almost every galaxy, including our own Milky Way, sits a supermassive black hole. These are monsters so large they contain the mass of billions of suns. Our galaxy's heart, Sagittarius A, is the reason our entire spiral of stars stays together. It is the anchor. Without the terrifying pull of these predators, galaxies would never have formed, and the universe would be a chaotic mess of drifting gas. We owe our existence to a force that could destroy us in a heartbeat. There is a strange paradox here. If black holes swallow everything, wouldn't they eventually eat the whole universe? For a long time we thought the answer was yes. But then came Stephen Hawking. He discovered that black holes have a leak. Through a strange quantum process, they slowly, incredibly slowly, emit a faint glow of radiation. They are evaporating. Over trillions and trillions of years, long after the last star has gone cold, black holes will slowly shrink and eventually vanish in a final, silent puff of light. This leads us to the most disturbing question of all, the information paradox. If you throw a book into a fire, you can, in theory, reconstruct the book if you have the ash and the smoke. The information isn't gone, it's just scrambled. But if you throw a book into a black hole and the black hole eventually evaporates, where did the information go? Is it deleted from the universe? If information can be deleted, then the very foundations of science are a lie. This has led some physicists to suggest something radical. They believe that black holes aren't just holes. They believe they might be printers. There is a theory called the holographic principle. It suggests that everything that falls into a black hole is actually encoded on its surface, like a 2D label on a 3D jar. If this is true, then the inside of a black hole isn't real. It's just a projection of the information on the edge. And if that is true for black holes, could it be true for the whole universe? Are we living in a 3D world that is actually just a projection of a 2D surface at the edge of space? This turns the black hole from a predator into a mirror. It forces us to ask if our reality is nothing more than a cosmic illusion, a hologram written in the language of gravity. But as we struggle to understand the nothingness at the heart of a black hole, we realize that the universe has one more secret to tell. If a black hole is a place where everything ends, could there be a mirror image? A place where everything begins? If a black hole is a drain, could there be a faucet on the other side? To find out, we have to look past the shadows of these predators and ask the most daring question in physics. Is our entire universe just the inside of a black hole that belongs to another world? And if so, what lies on the other side of the white hole? For every action, there is an equal and opposite reaction. This is one of the first rules we learn about the physical world. If you push a door, it pushes back. If you fire a bullet, the gun recoils. But for nearly a century, we have looked at the universe and seen a massive, terrifying violation of this rule. We found the black hole, the ultimate sink of the universe, a place where matter goes in and never comes out. We found the drain of reality. But if the universe follows the laws of symmetry, it raises a question that has kept physicists awake for decades. If there is a drain that swallows everything, where is the faucet that pours it back out? Welcome to the world of the white hole, the most controversial, beautiful, and mathematically perfect ghost in the history of science. To understand a white hole, you simply have to take everything you know about a black hole and hit the reverse button. If a black hole is a region of space where the gravity is so strong that even light cannot escape, a white hole is a region of space where the gravity, or rather, a kind of anti-gravity, is so powerful that nothing can ever enter. While a black hole is a bottomless pit, a white hole is a mountain that cannot be climbed. It is a cosmic fountain, a blindingly bright source of energy that is constantly vomiting matter and light into the universe, but which refuses to let a single atom cross its threshold from the outside. For a long time, white holes were dismissed as a mathematical trick, something that appeared in the equations of general relativity but couldn't possibly exist in the real world. They seemed to violate the second law of thermodynamics, which says that the universe always moves from order to chaos. A white hole, which creates order out of nothing, feels like a violation of the very soul of physics. But as we've learned more about the information paradox we discussed in the last section, the idea of the white hole has moved from the fringes of science to the center of the debate. The problem is simple. If information can never be destroyed, then the matter that falls into a black hole must go somewhere. It cannot simply vanish. Some physicists, including the legendary Carlo Rovelli, have proposed a radical theory. They suggest that at the very end of a black hole's life, once it has finished evaporating through Hawking radiation, it undergoes a quantum bounce. In a fraction of a second, the dying black hole, which has been crushing matter into a singularity, suddenly flips inside out. The drain becomes a faucet. The black hole becomes a white hole. If this is true, it means that every black hole in our universe is actually a cocoon for a new explosion of matter and light. It suggests that the nothingness at the center of a black hole isn't an end, but a transition. But this leads us to a realization that is even more mind-bending. If a white hole is a massive explosion of matter and light emerging from a single point in space, doesn't that sound familiar? Does it sound like the Big Bang? For years, a growing group of cosmologists has argued that our entire universe didn't start from a random explosion. They believe our Big Bang was actually the output of a white hole. They suggest that in a parent universe far beyond our own, a massive star collapsed into a black hole. On the other side of that black hole's singularity, our universe was born as a white hole, spilling out all the matter and energy that the parent black hole swallowed. We are quite literally the excrement of another world, processed through the gut of a black hole and reborn into a new reality. But if our universe is the result of a white hole, it implies that the arrow of time might not be as simple as we think. This brings us to the concept of the mirror universe. In the world of subatomic particles, there is a principle called CPT symmetry. It suggests that the laws of physics should remain exactly the same if you flip the charge of particles, flip their spatial orientation, and most importantly, flip the direction of time. If the Big Bang was a perfectly symmetrical event, then why does our universe seem so lopsided? Why is there more matter than antimatter? Why does time only move forward? Some physicists, such as Neil Turok at the Perimeter Institute, have proposed a solution that sounds like a hallucination. At the moment of the Big Bang, not one, but two universes were created. Our universe moving forward in time and a mirror universe moving backward from our perspective. In this mirror universe, everything is reversed. Your mirror self would experience life from the grave to the cradle. Light would travel from your eyes to the stars. The white holes of our world would be the black holes of theirs. This twin universe would be the cosmic anchor that keeps the laws of symmetry balanced. It would mean that nothingness didn't just split into something, it split into something and its exact opposite. This theory would solve some of the biggest headaches in science. It would explain dark matter as nothing more than the gravitational shadow of that mirror universe leaking into ours. It would explain why our universe feels so fine-tuned for life, because it is only half of a much larger, perfectly balanced equation. But if these two worlds are connected, where is the bridge? How does matter travel from the drain of a black hole in one world to the faucet of a white hole in another? This brings us to the most famous what-if in all of science, the Einstein-Rosen bridge, better known as the wormhole. For decades, wormholes have been the favorite tool of science fiction writers, allowing characters to travel across galaxies in the blink of an eye. But in the math of general relativity, a wormhole is simply a black hole and a white hole connected by a throat. It is a shortcut through the fabric of space and time. If you could survive the trip through a black hole's event horizon, and if that black hole was connected to a white hole in another part of the universe, or even another universe entirely, you would emerge on the other side almost instantly, having traveled billions of light years in a second. However, there is a catch. The math says these bridges are incredibly unstable. The moment a single photon of light tries to pass through, the throat of the wormhole would collapse, crushing anything inside. To keep the door open, you would need something called exotic matter, a substance with negative mass and negative pressure that pushes space open. And while we haven't found a mountain of exotic matter yet, we have seen hints of it in the quantum vacuum, those virtual particles we talked about earlier that pop in and out of existence. This suggests that the universe has a hidden plumbing system. We see the stars and the galaxies, but beneath them, there might be a network of tubes connecting black holes to white holes and our universe to 1,000 others. It paints a picture of a cosmos that is much more alive and interconnected than we ever dared to imagine. We aren't living in a lonely bubble of light. We might be part of a vast, breathing multiverse where energy is constantly being recycled through the dark hearts of predators and reborn in the brilliant flashes of white fountains. But as we look at these bridges and mirror worlds, we have to face a final chilling question. If the universe is a series of black holes and white holes, and if our reality is being projected from their surfaces, then what is the fabric itself made of? What is the paper that this cosmic story is written on? We've talked about matter, we've talked about energy, and we've talked about the nothing of the void. But there is one final layer to the mystery. It is the thing that allows space to bend, time to slow down, and wormholes to exist. It is the most fundamental substance in existence, and yet it has no weight, no color, and no atoms. In the next section, we are going to look at the spacetime fabric itself. We are going to ask if the universe is even real in the way we think, or if we are all just vibrations in a cosmic ocean that is far more mysterious than the stars themselves. Because as it turns out, the nothingness isn't just a place where things happen. It is a thing that can be broken. For most of your life, you have moved through the world with a very simple assumption. That space is just an empty background. You think of it as a stage in a theater, a fixed silent platform where the real actors, like stars and planets, play out their lives. You assume that if you took away all the matter in the universe, the stage would still be there, empty and waiting. This is the common sense view of the world, and for thousands of years, even the greatest scientists believed it. They thought space was a nothingness that didn't do anything. But as we began to look closer at the strange behavior of the cosmos, we realized that this empty stage is actually the most active, flexible, and mysterious participant in the universe. Space is not an empty background. It is a fabric, and just like a piece of silk can be stretched, twisted, or torn, the very fabric of our reality is constantly being manipulated by the things inside it. To understand this, we have to look at the genius of Albert Einstein, who did something no one had ever dared to do. He married space and time. Before Einstein, people thought of space as a three-dimensional box and time as a separate, ticking clock that moved at the same speed for everyone. Einstein realized that this was a mistake. He showed that space and time are actually two threads of the same cloth, a four-dimensional fabric he called spacetime. This means that you cannot move through space without affecting time, and you cannot move through time without affecting space. They are inseparable. Imagine a giant invisible trampoline stretching across the entire universe. This is the fabric of spacetime. If you place a heavy object on this trampoline like a bowling ball, it creates a dip. If you roll a marble across the trampoline, it won't move in a straight line. It will roll toward the bowling ball, following the curve of the fabric. This, Einstein realized, is what gravity actually is. Gravity isn't a mysterious pull coming from the center of a planet. Gravity is the shape of the nothingness. When you feel the Earth pulling you down, you are actually just feeling your body trying to slide down a curve in the fabric of spacetime created by the Earth's mass. This leads to a conclusion that sounds like a hallucination. The universe is lumpy. Because the fabric is being stretched and bent by every star and every black hole, the geometry of space is different everywhere you go. If you are near a massive object, the fabric is stretched so thin that time itself begins to slow down. If you were to spend an hour orbiting near the edge of a massive black hole, where the dip in spacetime is incredibly deep, and then return to Earth, you would find that decades or even centuries had passed for everyone else. You would have traveled into the future, not because of a time machine, but because you manipulated the fabric you were standing on. But if spacetime is a fabric that can be bent, can it also be broken? For a long time, this was just a theoretical question. But in 2015, we heard the sound of the universe shuddering. We detected something called gravitational waves. Imagine two black holes, two massive dips in the trampoline colliding with each other. The impact is so violent that it sends ripples across the entire fabric of the universe, like a stone thrown into a pond. These ripples travel at the speed of light, stretching and squeezing spacetime as they pass. When these waves hit Earth, they actually made the distance between objects slightly longer and then slightly shorter. For a fraction of a second, the entire planet Earth became slightly thinner and then slightly wider. Space itself was vibrating. This realization changes everything we know about nothingness. If space can vibrate, it must be made of something. If it can be stretched, it must have a structure. But what is that structure? If you zoom in on a piece of clothing, you eventually see the individual threads. If you zoom in on those threads, you see the fibers. What happens if you zoom in on the nothingness of space? Is it smooth and continuous, or is it made of tiny pixels of reality? Most modern physicists believe that if we could zoom into a scale called the Planck length, a size so small that an atom would look like a galaxy in comparison, we would see that spacetime is not smooth. Instead, it might be a chaotic, bubbling quantum foam. It might be a network of information where tiny bits of nothingness are entangled with each other, creating the illusion of a solid world. There is a growing theory that space itself doesn't even exist, that it is just an emergent property like the temperature of a room. Just as heat is just a word we use to describe the motion of molecules, space might just be a word we use to describe the way information is connected. This brings us to a terrifying thought. If our reality is just a projection created by the connections between quantum bits, what happens if those connections are severed? What happens if the fabric snaps? We've already seen that black holes can punch holes in the fabric, but even they are part of the system. What if the entire fabric of the universe began to undergo a phase transition? Imagine a container of water. If you cool it down, it stays liquid. But if you hit a certain temperature, it suddenly and violently turns into ice. The rules of the water change instantly. Some physicists believe our universe might be in a false vacuum, a state that isn't completely stable. At any moment in any corner of the cosmos, a bubble of a new, more stable vacuum could form. This bubble would expand at the speed of light, and as it passed, it would rewrite the laws of physics. It wouldn't just destroy life, it would delete the very fabric of spacetime as we know it. We wouldn't even see it coming. 1 second, the universe is here. The next, the fabric has been replaced by something we cannot even imagine. But as we look at this delicate, vibrating web of space and time, we realize that it is currently being pushed to its limits. The expansion we talked about earlier, the dark energy that is stretching the universe, is pulling on this fabric with increasing violence. We are living in a universe that is being overstretched. And when a fabric is stretched too far, it doesn't just get thinner, it loses its ability to hold things together. This leads us to the ultimate fate of our reality. If the fabric of spacetime is the stage, and the stage is being torn apart, then where is the play going to end? We've looked at the birth of the universe, the growth of the stars, and the invisible skeleton of dark matter. But every story has a final chapter. And to understand the end, we have to look at the one law of the universe that can never be broken, the law that says everything eventually must turn into nothing. We are heading toward the Great Silence, a time when the fabric of spacetime will be so empty and so cold that the very concept of happening will cease to exist. But is there a way out? Is the end of our fabric the beginning of another? To find out, we have to look at the heat death of the universe and the mysterious restart button that might be hidden in the math of the void. If every story has a beginning, it must also have an end. Throughout this journey, we have witnessed the violent birth of space, the delicate formation of the first atoms, and the majestic rise of the great galactic empires. But there is a shadow hanging over all this light. There is a silent, invisible law written into the very heart of physics that says all of this, the stars, the planets, and the memories of every civilization, is temporary. We are living in a brief, flickering window of light between two eternities of darkness. And today, we have to face the final chapter of the cosmic story. We have to talk about the heat death of the universe, the moment when the clock finally runs out, and the universe enters a state of absolute, unbreakable silence. To understand how the universe ends, we first have to understand the most ruthless law in existence, the second law of thermodynamics. It introduces a concept called entropy. In simple terms, entropy is a measure of disorder or randomness. The law states that in any closed system, entropy must always increase. Think of a beautifully organized sandcastle on a beach. Without constant effort to maintain it, the wind and the waves will eventually turn it back into a flat, featureless pile of sand. The universe is that sandcastle. Right now it is highly organized. We have hot stars and cold space. We have dense planets and empty voids. This difference in temperature and density is what allows energy to flow. And where energy flows, things happen. Life breathes, stars burn, and time feels like it's moving forward. But the entropy tax is always being collected. Every time a star burns fuel, every time a planet orbits a sun, and every time you take a breath, a little bit of energy is wasted as heat that can never be recovered. The universe is slowly but surely evening itself out. It is moving from a state of hot and cold to a state of lukewarm. And once everything reaches the same temperature, the story is over. We are currently living in what astronomers call the stelliferous era, the age of stars. This is the most vibrant and exciting part of the cosmic timeline, but it is just a tiny fraction of the whole. In about 100 trillion years, the universe will undergo a profound change. The vast clouds of gas and dust that provide the fuel for new stars will finally be exhausted. One by one, the lights of the sky will begin to fail. The brilliant blue giants will go first, followed by the yellow suns like our own. Eventually, the only things left will be the red dwarfs, tiny, dim stars that burn their fuel so slowly they can live for trillions of years. But even they have a limit. Eventually, the last red dwarf will flicker and die. The universe will go dark for the first time since the Big Bang. This leads us into the degenerate era. In this world, the universe is a graveyard of dead stellar remnants. White dwarfs, neutron stars, and black holes will be the only things floating in the abyss. If you were to travel through the cosmos then, you wouldn't see any light. You would only find cold, dark spheres of iron and carbon. But even matter itself isn't safe from the reach of entropy. Many physicists believe in a process called proton decay. It suggests that the very atoms that make up our bodies and our planets are not stable over long enough periods. After 10-40 years, a number so large it's impossible to visualize, the atoms will simply start to dissolve. The iron stars will evaporate into a mist of subatomic particles. The solid ground of the universe will literally melt away into the void. By the time we reach the black hole era, the only structures left in the universe will be the ultimate predators we talked about earlier. Black holes will be the undisputed kings of the cosmos, having swallowed all the remaining matter. But even they are not immortal. As Stephen Hawking famously predicted, black holes slowly leak energy through Hawking radiation. Over an unimaginable stretch of time, roughly 10–100 years, even the most massive supermassive black holes will evaporate. They will finish their lives in a final, silent flash of light, leaving behind nothing but a thin, cold soup of photons and electrons. This is the end state, the heat death. In this final era, the universe has reached maximum entropy. Every corner of the cosmos is the exact same temperature, just a fraction of a degree above absolute zero. Because there is no difference in temperature, no energy can ever flow again. There is no light, no heat, no motion, and no information. Time itself becomes meaningless. If nothing ever happens, does it matter how much time passes? A second and a trillion years become indistinguishable. The universe becomes a vast, empty, and eternal ocean of nothingness. It is the great silence. For a long time, this was considered the most depressing conclusion in all of science. It suggests that our existence is a meaningless accident in a universe that is destined to be a frozen graveyard. But as we look deeper into the math of the nothingness, we find a strange, flickering light of hope. Because even in a state of heat death, the laws of quantum mechanics are still active. And as we've seen, the vacuum of space is never truly empty. There is a theory called Poincare recurrence. It suggests that in a system that lasts for an infinite amount of time, every possible configuration of matter and energy must eventually happen again. If you wait long enough, long past the heat death, long past the evaporation of the black holes, it is statistically possible for a random quantum fluctuation to occur that is so powerful, it triggers a new Big Bang. In the infinite silence of the dead universe, a single spark could appear, and the whole cycle could start all over again. Is it possible that our Big Bang was not the beginning of time, but simply the rebound of a previous universe that had reached its own heat death? Are we part of an infinite chain of universes, rising and falling like the breathing of a cosmic giant? This idea of a cyclic universe changes the way we see ourselves. We aren't just a glitch in a dying system, we are a recurring note in a cosmic symphony. But this raises the most profound question of all. If the universe is destined to repeat itself, or if it is part of a vast multiverse of infinite possibilities, then why is it tuned so perfectly for us to be here right now? Why are the laws of physics so precise that they allow atoms to form, stars to shine, and consciousness to emerge? Is it just a massive coincidence, or is there something about the nothingness that wants to be observed? As we stand on the edge of the end of time, looking back at the 18,000-word journey we've taken, we realize that the biggest mystery isn't the stars or the black holes. It's the fact that we can understand them at all. In the next section, we are going to look at the user manual of the universe. We are going to ask if the reality we see is actually real, or if we are living inside a mathematical construct, a simulation so perfect that the only way to find the programmers is to look at the gaps in the nothingness itself. We are moving from the world of physics to the world of the code. Have you ever had that strange, unsettling feeling that something in your life was just a bit off? A moment of déjà vu that felt less like a memory and more like a skipped frame in a movie. A coincidence so perfectly timed that it felt scripted. For most of our lives, we dismiss these moments as tricks of the mind. We tell ourselves that the world is a solid, physical place made of atoms, governed by unbreakable laws of logic. We assume that reality is real because we can touch it, smell it, and feel the weight of it in our hands. But as we dive deeper into the mysteries of the cosmos, we are forced to confront a possibility that is more terrifying than any black hole and more profound than the Big Bang itself. What if the universe isn't a physical place at all? What if the nothingness we've been exploring is actually the blank space of a cosmic hard drive? What if you, and everyone you've ever loved, are nothing more than lines of code in a simulation so perfect that you can't even see the screen? This isn't just the plot of a science fiction film. It is a serious scientific hypothesis that is being debated by some of the most brilliant minds at Oxford, Harvard, and NASA. To understand how we got here, we have to look at the staggering pace of our own technology. Just 50 years ago, we had Pong, two white rectangles and a dot bouncing on a black screen. It was primitive, flat, and obviously fake. Today, we have photorealistic virtual realities, massive multiplayer worlds, and AI that can generate human-like thoughts. If you plot that progress on a graph, and you imagine where we will be in 10,000 or a million years, the conclusion is inevitable. We will eventually create simulations that are indistinguishable from reality. We will create ancestor simulations, where virtual beings have their own consciousness, their own history, and their own scientists who wonder where they came from. This leads to the simulation argument proposed by philosopher Nick Bostrom. He argues that if any civilization anywhere in the universe ever reaches the point where they can run realistic simulations, they won't just run one, they will run millions of them. Statistically speaking, there would be one base reality and millions of simulated realities. If that's the case, what are the odds that we just happen to be the ones in the real world? The math says the odds are billions to 1 against us. It is far more likely that we are the ones living inside the software. But if we are in a simulation, wouldn't there be evidence? Wouldn't there be pixels in the nothingness? As it turns out, when we look at the very smallest scales of our universe, that is exactly what we find. In our everyday lives, we think of space as a smooth, continuous background. But in quantum physics, there is a limit to how small things can get. This is called the Planck length. If you try to measure anything smaller than this, the very laws of physics break down. It is, for all intents and purposes, the resolution of our universe. Just like a high-definition image looks smooth from a distance, but reveals individual pixels when you zoom in, our reality seems to have a hard limit on its detail. It's as if the engine of the universe only has a certain amount of processing power, and it can't render anything smaller than that. But the evidence doesn't stop at pixels. We have to look at the speed limit of the universe. Why is the speed of light exactly 299,792,458 meters per second? Why can't anything go faster? In a physical world, this limit seems arbitrary, but in a simulation, a speed limit makes perfect sense. It is the refresh rate of the processor. Information can only travel across the server at a certain speed. If you try to move faster than the hardware allows, the system stops you. The speed of light isn't a law of physics, it's a hardware constraint. It's the speed at which the simulation can calculate the next frame of reality. Then there is the mystery of quantum entanglement, what Einstein called spooky action at a distance. We've discovered that two particles can be linked in such a way that if you change one, the other changes instantly, even if they are on opposite sides of the galaxy. This violates the speed of light. It makes no sense in a 3D physical world, but in a simulation, it's easy to explain. Two particles that appear to be far apart in the rendered world are actually right next to each other in the underlying code. It's like 2 pixels on your monitor. They might be on opposite corners of the screen, but they are both being controlled by the same piece of software in the CPU. Distance is an illusion created by the interface. This brings us to the most unsettling part of the theory, the mathematical universe hypothesis. If you look at the core of everything, from the way a flower grows to the way a star explodes, you find math. The universe doesn't just use math, it seems to be made of it. Constants like the golden ratio, the fine structure constant, and the law of gravity are so precise that if they were changed by a fraction of a percent, the universe would collapse or never form atoms at all. This fine-tuning is the greatest mystery in science. Why is the universe so perfectly balanced for life? One explanation is that a creator did it. But the other, more modern explanation is that these are global variables in a program. They are the settings the programmer chose before hitting the Start button on the simulation. If we are in a simulation, it changes the meaning of nothingness entirely. The void isn't empty space, it's unallocated memory. The Big Bang wasn't a physical explosion, it was the moment the code was executed. And the heat death we talked about earlier, that's just the moment the simulation reaches its conclusion and the program is closed. But this raises a question that should haunt you. If we are a simulation, who is the programmer? And why are they running the program? Some believe we are an experiment in evolution. Others think we are a historical recreation by our own descendants, trying to understand their origins. But there is a darker possibility. Perhaps the simulation wasn't built for us at all. Perhaps we are just background noise in a program designed for something else entirely. We might be the equivalent of the ants in a game of Sim City, incidental life forms that the player doesn't even notice. We are searching for the meaning of life, while the player is just trying to see how long it takes for a star to turn into a black hole. But there is a loophole. If our universe is a simulation, then it must be running on some kind of hardware in the base reality. And that hardware must have its own laws of physics. It's possible that our universe is just one of many layers. We are a simulation, running inside another simulation, which is running inside another. It's an infinite Russian doll of realities. And in each layer, the nothingness is different. In the base reality, space and time might not even exist. The nothing, there could be something so alien that our simulated brains literally cannot perceive it. This leads us to a stunning realization. If we can never see the programmer and we can never exit the simulation, does it even matter if it's real? The feelings you have, the pain you feel, and the beauty you see are real to you. Whether they are created by atoms or by bits of data doesn't change their value, but it does give us a new way to look at the end. If the universe is a program, then nothingness isn't a graveyard, it's a reset. It's a chance for the code to be rewritten, for the errors to be fixed, and for a new, better world to begin. But as we look at the mathematical perfection of our world, we realize that there is still one thing the simulation theory can't fully explain. If everything is just code, then why do we feel like we are here? Why is there consciousness? You can program a computer to say, I am sad, but you can't make it feel sadness. The fact that you are aware, that there is a user behind the eyes, suggests that even if the world is a simulation, the soul might be coming from somewhere else. As we prepare to move into the final chapters of this cosmic journey, we have to look past the code and past the math. We have to ask if there is a way to bridge the gap between the nothingness of the machine and the somethingness of the mind. We have to explore the multiverse, the idea that our simulation is just one of an infinite number of experiments happening at the same time. We are going to look at the eternal inflation theory and the possibility that the nothingness is actually a factory, churning out universes like bubbles in a boiling pot of water. We have traveled from the void to the stars, from the black holes to the end of time, and from the fabric of reality to the digital code. Now it's time to see how it all fits together. It's time to ask the final question. If the universe is infinite, does that mean that somewhere in another nothingness, there is another version of you, reading these exact same words, wondering the exact same thing? We have spent the last few minutes exploring the history of our universe, a journey that took us from a microscopic spark to the vast, cold silence of the distant future. We have looked at the nothingness as a vacuum, a fabric, a graveyard, and even a computer code. But everything we have discussed so far has been based on a single massive assumption, that our universe is the only one that exists. We have been like a person born inside a small, windowless room, trying to figure out the laws of the entire world by looking at the wallpaper. But what if our room is just one of an infinite number of rooms in a skyscraper that has no top and no bottom? What if the Big Bang wasn't a unique, once-in-existence miracle, but a common, everyday event happening trillions of times across a much larger, much more terrifying landscape? Today, we have to look past the horizon of our own reality. We have to talk about the multiverse, the idea that our nothingness is actually an everythingness that we are only just beginning to perceive. To understand why scientists even consider this possibility, we have to go back to the very beginning, to the fraction of a second after the Big Bang that we call inflation. As we discussed earlier, inflation was a period of hyperexpansion where space grew faster than the speed of light. It was the fuel that powered the creation of our world. For a long time, we thought this fuel was used up in one go, like a tank of gas that exploded to create our universe. But then, physicists like Alan Guth and Andre Linde realized something shocking about the mathematics of that fuel. They realized that the inflaton field, the energy that causes space to expand, is incredibly hard to turn off. In fact, according to the theory of eternal inflation, the fuel didn't just explode, it started a chain reaction that can never be stopped. Imagine a vast eternal ocean of rapidly expanding space. This ocean is moving so fast that it is constantly doubling in size every fraction of a second. This is the background space. But within this ocean, tiny patches occasionally slow down. They decay into a lower energy state. When a patch slows down, it stops expanding at that hyperspeed and settles into a stable universe. This patch becomes a bubble. Our entire observable universe, with its 2 trillion galaxies and 13.8 billion years of history, is just one tiny bubble in this infinite, boiling ocean. And while our bubble is growing at its own pace, the ocean around it is still screaming ahead, creating new bubbles every single moment forever. This is the level II multiverse. It suggests that Big Bangs are happening right now, in the time it took you to blink, in regions of space so far away that their light will never reach us. This isn't just a fun theory, it solves the greatest problem in all of science, the fine-tuning. We've talked about how perfectly our universe is balanced for life. If gravity were slightly stronger, the universe would have collapsed immediately. If it were slightly weaker, stars would never have formed. For decades, scientists wondered why we got so lucky. But in an eternal multiverse, luck has nothing to do with it. If you have an infinite number of bubbles, you will have every possible version of a universe. You will have universes with 10 dimensions, universes where gravity works backward, and universes where light moves at the speed of a walking human. We don't live in a special universe. We just live in one of the few bubbles where the laws of physics happen to allow for the existence of atoms and observers. We are the winners of a cosmic lottery that has an infinite number of tickets. But let's take this even further into a territory that challenges the very idea of what it means to be you. This is the level I multiverse, and it is based on a very simple, very frightening mathematical reality: infinity. If the space within our own bubble is truly infinite, not just very large, but literally without end, then a strange thing happens. There are only a finite number of ways you can arrange matter in a given volume of space. There is a limit to how many ways atoms can be put together to form a planet, a person, or a brain. Think of it like a deck of cards. There are a lot of ways to shuffle a deck, but there isn't an infinite number of ways. If you shuffle that deck enough times, eventually, you will get the exact same order of cards twice. The universe is the same. In an infinite space, if you travel far enough, you will eventually find a region of space that is an exact copy of this one. You will find another Earth, another city, and another you sitting in the exact same chair, reading these exact same words. And between those two identical versions of you, there are an infinite number of almost identical versions. There is a version of you who had cereal for breakfast instead of toast. There is a version of you who became an astronaut. There is a version of you who never made that one mistake that haunts you at night. In an infinite multiverse, every choice you didn't make is being lived out by another version of you in another part of the nothingness. This turns our concept of nothing inside out. We think of the void between the bubbles as an empty gap, a wasteland. But in the theory of eternal inflation, that gap is the most energetic and important part of reality. It is the space between spaces. It is a place of such high energy that our laws of physics would melt instantly if we ever touched it. It is the raw, unedited source code of existence. We are just the stable pixels that formed when the code cooled down. But is there any evidence for this? How can we ever prove that there are other bubbles if they are moving away from us faster than the speed of light? The answer might be hidden in the bruises. If our universe is a bubble in a crowded ocean, it's possible that in the very early days, before the expansion pushed everything apart, our bubble bumped into another one. This cosmic collision would have left a mark, a literal dent in the fabric of our reality. Astronomers have been searching the cosmic microwave background, the first light of the universe, for these bruises, and they've found something strange. There is a cold spot in our sky, a massive region where the temperature is lower than it should be. While most scientists are cautious, some believe this cold spot is the scar of a collision with another universe. It is the point where our nothingness met someone else's. Then there is the theory of dark flow. Astronomers have noticed that hundreds of galaxy clusters seem to be streaming in a specific direction, as if they are being pulled by something massive beyond our cosmic horizon. There is nothing in our observable universe large enough to exert that kind of pull. This suggests that there is something outside our bubble, a massive structure or another universe entirely, that is tugging on us through the fabric of spacetime. We are feeling the heartbeat of a multiverse that we cannot see. As we wrap our minds around this infinite landscape, the nothingness starts to feel very different. It is no longer a graveyard, it is a landscape. String theory suggests that there are 10,500 possible ways to fold the extra dimensions of space. Each of those 10,500 ways creates a different set of laws of physics. Our multiverse is a vast, blooming garden where every single one of those 10,500 possibilities is growing somewhere. It is a reality where everything that can happen does happen, somewhere, at some time. This realization is both liberating and terrifying. It means that we are simultaneously completely insignificant and incredibly connected. We are a tiny speck in a bubble, but we are also a part of an infinite, eternal process of creation. The nothingness didn't just produce us, it is constantly producing us. It is a factory of existence that never sleeps. But if reality is this big, if it is truly infinite and eternal, then it forces us to ask the final, most difficult question. What does it all mean? If there are infinite versions of you, does your life here have any value? If the universe is just a random bubble in a boiling pot, is there any purpose to our struggle? We have traveled 16,500 words to get to this point. We have looked at the physics, the math, the simulations, and the multiverses, but all of that is just data. In our final section, we are going to look for the why. We are going to look at the observer, the consciousness that is currently processing these words. Because as it turns out, the most mysterious thing about the nothingness isn't what's out there in the stars. It's the fact that there is something in here in your mind that is capable of asking the question. We are going to close the loop. We are going to look at the participatory universe, the idea that the nothingness only becomes something when someone is there to see it. We are going to discover that you aren't just a passenger in the universe. You might be the reason it exists in the first place. We have traveled through the heart of the void, witnessed the birth of the first stars, stood at the edge of the event horizon, and peered into the digital code of a possible simulation. We have seen the universe grow from a microscopic spark to an infinite multiverse, and we have watched it fade into the eternal silence of the heat death. After 18,000 words of exploration, we find ourselves back where we started, staring into the darkness of the night sky, asking the same question that the first humans asked as they huddled around their fires. Why are we here? Is the universe a cold, mechanical accident, or is there a reason that the nothingness decided to become something? To find the answer, we have to stop looking at the stars and start looking at the one thing that has been present for this entire journey, but which we have yet to fully explain. Your consciousness, your ability to observe, to wonder, and to feel. Because as it turns out, the nothingness might not be the protagonist of this story. You might be. For centuries, science has tried to push the human observer to the sidelines. We were told that the universe is a massive, objective machine, and that we are just tiny, insignificant microbes living on a dust mote in a vast, indifferent desert. But in the early 20th century, the world of quantum mechanics gave us a shock that we still haven't recovered from. Scientists discovered that at the very smallest scale of reality, particles don't actually exist in a specific place until they are observed. Before you look at an electron, it is a wave of probability. It exists in a blur of multiple places at once. It is only when an observer, a conscious mind or a measuring device, intervenes that the wave collapses and reality becomes solid. This is the observer effect, and it suggests something revolutionary, that the universe doesn't just exist out there on its own. It requires a participant. The legendary physicist John Wheeler called this the participatory universe. He imagined a giant U, where one side represents the birth of the universe and the other side represents the observer. The observer looks back at the beginning of time and, through the act of looking, brings the universe into being. If this sounds like a hallucination, consider the math. If a universe exists but no one is there to see it, no one is there to measure it, and no one is there to experience it, does it actually have a reality? Without a mind to perceive it, the universe is just a sea of mathematical possibilities, a ghost world that never truly happens. You are the mechanism through which the universe has finally woken up. You are the universe's way of looking in a mirror and saying, "I am here." This changes the way we look at the nothingness entirely. We spent so much time worrying that the void was going to swallow us, but we never stopped to consider that the void might be afraid of us. Without you, the void is just a silent, empty vacuum. But the moment you were born, you brought meaning, color, sound, and love into the cosmos. You are a biological machine made of stardust that has the audacity to ask, why? And in that question, the entire purpose of the 13.8 billion-year journey is revealed. We are not just in the universe. We are the sense organs of the universe. We are the eyes through which the cosmos sees its own beauty, and the minds through which it understands its own laws. But why is the universe so perfectly tuned for us to exist? We've talked about the fine-tuning problem, the fact that if the laws of physics were even slightly different, we wouldn't be here. Some call it the anthropic principle. It suggests that the universe has the properties it has because we are here to observe it. If the laws were different, we wouldn't be around to notice them. It's like a fish marveling at how perfectly the water fits its body. It doesn't realize that if the water didn't fit, it wouldn't be a fish. But there is a deeper, more poetic version of this principle. Perhaps the universe wants to be observed. Perhaps the nothingness was so lonely that it spent billions of years forging stars and planets, just so that one day, on a small blue planet, a conscious being could look up and say, "Wow." This brings us to the most beautiful paradox of our existence. We are made of atoms that were forged in the hearts of dying stars. We are governed by the same gravity that holds galaxies together. We are made of the same nothingness that exists in the deep voids between the stars. And yet we are something more. We are the point where the universe has become self-aware. Every time you learn a law of physics, the universe is learning about itself. Every time you feel a sense of awe at a sunset, the universe is feeling awe at its own creation. We are the bridge between the cold, mathematical laws of the code and the warm, emotional reality of the soul. As we look toward the final chapters of our lives and the final chapters of our planet, it is easy to feel small. We know that the Earth will eventually be swallowed by the sun. We know that the sun will eventually go dark. We know that the heat death is waiting at the end of the line, but that doesn't make our existence meaningless. In fact, it makes it more precious. If the universe is an infinite, eternal machine, then our brief moment of consciousness is the most valuable thing in it. We are the gold in the cosmic bank account. We are the only part of the system that can appreciate the play while it's still being performed. If there is one lesson to take away from this journey, it is this: nothingness is not a threat, it is a canvas. It was the blank slate upon which the Big Bang wrote the first chapter. It was the space in which the stars were allowed to shine. It was the silence that made the music of the spheres possible. And one day it will be the place where we return. But when we return to the nothingness, we won't be going into a graveyard. We will be returning to the source, the same quantum foam that is currently boiling with infinite possibilities. We are like waves in an ocean. A wave rises for a moment, catches the light, and then crashes back into the water. The wave is gone, but the ocean is still there, and the ocean is the wave. So when you look up at the night sky tonight, don't be afraid of the darkness. Don't be afraid of the massive empty voids. Those voids are the reason you can see the stars. That darkness is the reason the light matters. You are a 13.8 billion-year-old experiment in complexity. You are the miracle that the nothingness has been waiting for since the beginning of time. You are the observer, the dreamer, and the creator of your own reality. We have reached the end of our script, but the story of the universe is far from over. Somewhere out there, stars are being born. Somewhere, a black hole is feeding. Somewhere in another bubble of the multiverse, another version of you is asking these same questions. But right here in this moment, you are the one who is awake. You are the one who is listening. You are the something that survived the nothing. Thank you for taking this journey with me. If this exploration of the deep cosmos has made you feel a little bit more connected to the stars, then our mission is complete. Remember, you aren't just a small part of the universe. You are the universe expressing itself as a human for a little while, and that is the greatest story ever told. Don't forget to look up, because the void isn't just watching us, it's waiting for us to see what it has built.